Okay, here's warm-up number 28. I'm going to start by doing some synthetic division. You could also do long division. But heads up, there's a missing term. So imagine that there's a 0x squared in there. So when I set this up, I've got a -1 to represent dividing by x plus 1. So you take the opposite of that number, okay? And then my coefficients, but don't forget the 0 in there. Okay, I'll leave a space. All right, and I'm going to pull this 1 down, nothing to add it to, so 1 down here, and every time I get a number down here, I multiply by -1. Okay, and then these two I add, and multiply by -1, add these two, multiply by -1, add, multiply by -1, add one more time, and there we go, okay? And then I'm reinterpreting this into a polynomial. So this is the numerator of my remainder. My denominator is what I'm dividing by, in this case x plus 1. I always want to add my denominator, okay? And then this will just be a -9, and as I go to the left, I add 1 degree of x every time, so this would be 7x. This is going to be -7x squared. I'll put a plus there to separate it. And this would be an x to the third. And there is my solution. Okay. All right. So next up, this says, given one factor, factor the polynomial completely and find the zero. So they're telling us x minus 1 is a factor of this larger polynomial. So what I'm going to do, I can't really, you could try factoring this by grouping, but it's not going to work. So what I'm going to do is just divide out x minus 1 and see what's left from this when I divide it out. Okay? So I'm going to do that with synthetic division again. So I've got a 1 in my box here, and here's my coefficients from that larger polynomial. Okay, let's see, I'll pull down the 1. 1 times 1 is 1. -3 plus 1 would be -2. And then -2 times 1 is -2. 9 plus -2 is 7. 7 times 1 is 7, and then add that up. And sure enough, that does show me that this is a factor because it went in evenly. There was no remainder, okay? So that's one reason to do the division, is to check that that's actually a factor. But, you know, assuming that whoever wrote the problem isn't lying to us, we already kind of knew that. But the other reason is because then I can use this row, and that tells me what's left over after I divide out the x minus 1. So, you know, this is my remainder. This would be 7, -2x. This would be x squared. So it's going to begin with x squared minus 2x plus 7. Okay, so now I've got this broken down. And I'm going to see if I can factor this anymore. Maybe I can factor this trinomial. But when I set this up, it's going to be a dead end, because there's no two numbers that multiply to 7 and add to -2, at least no two integers. So I can't factor this anymore. So factor completely, well, we've already achieved that. So that's phase 1. But then we're also asked to find all of the zeros. Well, one of the zeros comes from this factor. So x equals 1. That's one of the zeros, okay? This should have 3 zeros because it's a third degree equation. The other two are going to come from the trinomial. Okay, so that's going to come from this equaling 0. It would be great if I could factor it, but I already tried that. It's not factorable, but that doesn't mean I can't solve for x. It just means I'm going to have to either use the quadratic formula or complete the square. And you can take your pick. It doesn't really matter. I'm going to complete the square here. So I'm going to be looking for the mystery number, which is not 7. So I'm going to move the 7 out of the way. I'm going to subtract 7 from both sides. So I moved that over to the other side. And then whatever I add to the left side, I got to add to the right side as well. Okay? So then my mystery number here, remember what you're going to do is take, you're going to do b over 2 squared. Okay, so b here is -2. So you're dividing -2 by 2, which would give you -1. And then squaring that. So the mystery number is going to be 1. So that's what I want to add to both sides. Okay, so now the left side of this is a perfect square trinomial, so it should factor into something times itself. So something squared. The right side is just -6. Okay, And let's think about that. This is going to be x minus 1 times x minus 1. You know, you could set up another diamond problem if you wanted to. And then there, that's factored on the left. Okay, so now I can take the square root of both sides of this equation. Don't forget you have a positive and a negative square root of negative 6. Okay, I'm going to add 1 to both sides to isolate the x. Okay, I'm going to slip that in front of the plus minus, and I could write plus minus square root of negative 6, but I really don't want to leave a negative under the radical. I want to write this as I root 6, okay? Because square root of negative 1 is I, right? And then there's no twins there. So these two are imaginary, but they're still solutions, okay? All right, and then the last problem, we're going to expand this binomial using Pascal's triangle. So I'm looking at the exponent. That's going to tell me which row to use. So row 4, be careful. The top row is not row 1. This is row 0, actually. So this is row 1, row 2, row 3, row 4. So I want the second to the bottom row here. Okay? And now I'm going to set up a little chart. The top row of my chart is going to be just those numbers from row 4. And I'm going to try to space them out a little bit to give myself room in the rest of the chart. Okay, and now the A is going to be 2x, and the B is going to be 3. Actually, the B is negative 3, sorry, because I'm thinking of those two added together. Okay, so A is 2x, and B is negative 3. So A row, I'm putting 2x all the way across. I'm going to put these in parentheses because I'm going to be raising them to different powers. And I don't want to just raise the x, I want to raise the quantity 2x to different powers. Okay, I'm going to do the same thing with the b's. Since it's a negative number, it's kind of important to put it in parentheses. To be safe, you can just always put all these in parentheses. But it wouldn't really matter if it was just like positive 3 or something like that. Okay, so then my exponents on the A and B rows, I'm going to, since this is 4th degree, I'm going to start with a 4 and work my way down to 0. And it should end up on 0. It did here. If it doesn't, you use the wrong row. And on the wrong row from the Pascal's triangle. And then I'm going to start with a 0 here and work my way up, and I should end up at 4 because it's 4th degree again. Okay, now all I have to do is multiply like this to get the different terms of the product. Okay, so this the first term is going to be 1 times, well, 2x to the 4th. Think of raising 2 to the 4th. 2 to the 4th is going to be 16, and then x to the 4th, so 16x to the 4th. Anything to the 0th power equals 1, so that's going to be my first term. Okay, and I'm going to add that to my second term. So I've got 4, and then 2x to the 3rd is going to be 8x to the quantity 2x to the 3rd is 8x to the 3rd. 2 times 2 times 2 is 8, right? Negative 3 to the first power is negative 3. Okay, and then I've got 6 times 4x squared times positive 9. Always have trouble fitting these on the paper, no matter how much I concentrate on it. And then I've got 4 times 2x times negative 27. Okay, I'm going to have to put this last one down here because I ran out of space. 1, anything to the 0th power equals 1. Negative 3 to the 4th. Well, negative 3 to the 2nd is 9, right? So it's going to be 9 times 9 because it's negative 3 to the 2nd times negative 3 to the 2nd. So this will come out to 81. Okay? And now I do the multiplication to get each term. So that first term, 16x to the 4th. Second one, 4 times 8 times negative 3. That's actually going to come out negative there, right? And that's going to be negative 96x to the 3rd. 6 times 4 times 9 is 216. Okay, 4 times 2 times negative 27 is going to come out negative. That'll be negative 216x. And then 1 times 81 is 81. Okay. on these problems, when you expand binomials like this, sometimes all the terms will be positive, sometimes they'll all be negative, and the other option is they will alternate signs. So that's, you see how we got positive, negative, positive, negative, positive. So it's either going to alternate or all the signs are going to be the same. Okay, and that's it for today's warm-up, and I will see you next time.